YouTube channel of Coding Club of RVCE. I'm Naman and we're discussing LeetCode question 3076, shortest uncommon substring in an array from LeetCode Weekly Contest 388. The question says that we have an array ARR of size n consisting of non-empty strings. We have to find a string array answer of size n such that each element of answer is the shortest substring of ARRI that does not occur as a substring in any other string in ARR. If multiple such substrings exist, answer I should be the lexicographically smallest. That means that answer I should be the one that appears the first one in the dictionary. And if no such substring exists, answer I should be an empty string. Finally, we have to return the array answer. So I'll explain the question and the conditions with the help of examples. But before that, let's move on to the constraints. So we can see that the length of strings given is pretty small, it's 100, and the size of each string is also 20, that is pretty small. So we can hope for a brute force approach or a time inefficient code that would go up till n square or m square, such that since the constraints are so low, it would still pass the test cases. So let's move on to understanding the question. Let's take this example first. So we have these strings. Now I've generated each of the substrings for each string. ABC has all of these substrings. Now for A, I can see that it occurs in the third string as well as a substring. B occurs in both of the strings. C occurs in both of the strings. Therefore, I cannot take any of these strings as the substring that does not occur in any other string. I can discard them. Similarly, AB and BC occur again, so I can discard them as well. And I can see ABC occurs as well, so I can discard it too. Since no substring of ABC is a unique string that does not occur in any other string as a substring, I can say that the answer for ABC would be an empty string. Similarly, for BCD, all of the strings that occur as a substring would occur here as well because BCD itself is a substring of ABCD. Therefore, I can discard all of these substrings and the answer is an empty string. For ABCD, I can see that all of these strings can occur before ABCD and all of the other strings. But the string ABCD is a unique string and it is also a substring of ABCD. That's why I can write it as the answer because it does not occur in any of the other strings. So this would be my final answer array. Let's check. Yeah. Now, moving on to the approach of the question. So this is the second example. To achieve what we want to, I'm going to maintain a global hash map that will store the frequency for each substring. It would account for the number of strings that this substring is a part of. So I can see that C here is a part of 2 strings. So I would say C corresponds to 2. Similarly, A for 3. So these are all of the substrings, and these are the strings that occur in multiple strings. But all of the remaining ones like CA, AB, CAB, and so on, all of these strings occur in a single string only as a substring. So their frequency would be 1. Now, for CAB, I have these 3 strings that are unique to this string, but I have to choose the lexicographically smallest. I can see that AB would be the first one to occur in the dictionary before CA and CAB. So the answer here would be AB. Over here, all of the strings are used, so it's an empty string. Over here, it's BA and BAD, so it would be BA since it occurs first in the dictionary, and here all of them are used, so it's an empty string. The answer is AB, empty, BA, empty, and that's correct. Moving on to the code. So this is the code for the problem. Now, first of all, I've taken the size of the array and I've created a vector of strings sub that stores all of the substrings for each of the string I. Now, I've also created a map of string to integer correspondence called count. This stores the number of strings that this substring is a part of. So as explained, the map would store C corresponds to 2 as C is a part of two strings as a substring. Now, for all of the strings available in the array, I take the string and I find its size. I also create a local map for each string. So the purpose of the local map is as such. So let's say I have a string BAB. Its substrings would be B, A, B, BA, AB, and BAB. I can see that B occurs twice here, but if I take the count of B as 2, that would mean that B is a part of B is a part of two strings as a substring, and that's wrong. So what I do is create a local map. The local map would say that B corresponds to 2, but the global map would say B corresponds to 1, and that is the purpose of the local map which I've used. So this is the local count. Now I generate all of the substrings. So this is a standard nested loop to generate all of the substrings. By the way, there are about m square substrings for a string of size m. So this is the substring generated, and then I increase its local count. If local count equals 1, that is, I'm encountering this substring for the first time in this particular string, then I increment its global count. And finally, I push that substring onto the vector or vector of substrings. Now I have to sort all of these substrings to attain lexicographical sorting, because finally we have to return the lexicographically smallest substring for each string. Uh, so this is the inbuilt sorting function in C++, but I've used a custom comparator here. This is the custom comparator, and I'll explain what that means. So for the standard sorting algorithms that we have, say we have two strings AB and AC that are of same size. It would return AB is less than AC because they're of same size. So it judges them, compares them on the basis of the first unequal character. But say if the strings were B and AB, it would return AB less than B because it judges only on the basis of the first character and A is smaller than B. Similarly, if it were B and CA, it would return B less than CA because on the basis of first character, B is smaller than C, and therefore uh, this is the smaller string in standard algorithms. In a dictionary, what we know is if the size of the two strings are same. So if AB and AC are the strings, I will return the smallest one. So that is the standard approach that first unequal character judges the precedence. So for AB and AC, AB comes before AC. But if size are different, so for B and AB, I would have to return B less than AB. And how do I do that? Is when sizes are different, I just return the one which is smaller to occur first. So I say that B has to occur first because it's smaller in size, because that's what happens in a dictionary. So that's what I've done here in the custom comparator. If the sizes of two strings are same, I return the smaller one. Otherwise, I return the one which has a smaller size. Now, this sorts all of my substrings in a lexicographical format so that I can easily achieve the smallest string which does not occur in any other string as a substring. So this is the initialization of the answer vector, and for each string, I traverse its substrings. The very first substring that occurs only as a part of one string, I take that as my answer and break the loop and go on to the next string. Finally, I return my answer. So that is the approach to this question. Let's try to run it. It works. Yeah. Moving on to time and space complexity. So for space, we're using this vector vectors and this map. So both of them take n into m square space if n is the size of the array and m is the size of each string given. Uh, That's all of the space that we need. The sorting function also uses some space, but we do not consider that usually. So the space used, including the space used by the local count map, would be n into m square, where n is the size of the array given and m is the size of each string. For time complexity, the generation of all substrings takes a big O of m square time, and the sorting algorithm takes m square log of m square. So since the sorting algorithm is the dominant one here, we consider that, and the overall time complexity for this whole for loop would be n into m square log m square. This loop as well has a time complexity of n into m square. So since that's lower than m square log n, we do not consider that. The final time complexity comes out to be n into m square into log of m square. And if you actually put in the constraints, n equals 100 and m equals 20, this comes out to be around 10 power 7 or something, and that falls in the category that would achieve all of the test cases as accepted. So that's it for this question, guys. See you guys next time.
Coding Club.